Hi there, Vox. Oh, do you hear us? It's so great to be here. I've never been so fun in such a bigger room. So how are you doing? Good. You'll be doing really good after this talk. Okay, so couple words about me. That's where I live. So it's a beautiful country. I come from Poland, but I live right now in Switzerland. I am developer, wizard, and an architect. Written a little bit differently, an architect, mostly involved for almost 20 years with Java and JVM-oriented stuff. And that's some of my Pokemons that I like or hate. And that's the company I work for. What we do, we just bring fun to the banking systems and insurances in Switzerland. And of course, we are hiring and we pay in Swiss francs. So keep that in mind. Okay. So today's story will be about, just a moment, will be about first bashing something. So bashing something that you probably know. Who knows Spring? Oh, a lot of you. Who programs with Spring almost like every day professionally? Cool, so it's for you. So this is something, let's say we have a typical problem that I'm sure most of you know this problem. You have a socks, and sometimes they are just missing another pair. And you know, when you have one sock only without a pair, it's a problem. So the people are trying to solve this problem. One way would be to create a service that will be like taking care of pairing a socks. So something like, let's build a Tinder for socks. So you can register a lonely sock, and then you can like find a pair for that. Maybe other people have your pairs, whatever. So a sock is something that has a name, some special marks, and of course might be paired with another sock. So we create something like this, entity class, let's say. That's our model. Then what we do is maybe we create something like a sock service that takes entity manager. I hope this code is quite easy to understand. Is it easy to understand? Raise your hand. Okay, cool, because I have a lot of code, don't want to explain everything, but this is classical Java, and we have the most important operation, pairing socks, where we say the name of one sock, the name of second sock, and then we pair them, maybe we unpair them. What's important, we do it in transaction. And then finally we create a controller, because it of course must be a RESTful controller, because on the front we'll have Angular and everything will be perfect. And then we create this operation like request mapping pair. We have name of the first sock, name of the second sock, then we call the service and we are done. And who is doing REST services like that? Cool. So what's great about it? There is something like Spring, or even you might even use Spring Boot, whatever. It takes care about everything, about wiring. We have a request mapping, so we map to something. Then we have we map to some context path, to socks. Then we have operation mapping. We can map posts, gets. Is this code clear? When you read it, do you know what it does? Right? Is it clear? Yeah, for me this is a clear code. While reading that, I know the intention and I know what's supposed to be working. This is cool. And the thing is, however, there are some problems with this kind of code. Like, about this controller. Let's look at this. We have a controller that's just a pairing. Let's test pairing. How would you test this method? Okay, some people would say, it doesn't make a sense to test controllers. We just test services. But what if you have some more sophisticated logic about HTTP, like you are checking security or whatever? How can you test that? So the thing that we are mostly doing, we are doing such tests, like we mock a service, then I make it smaller, then we create a, let's say, test version of our object, which is now started without Spring. We created with a new method. We pass the dependency. By the way, that's dependency injection. We had a a stock controller with dependency to the service. Then we test it when we check the service. The thing is, we have checked the method, but did we check if, for instance, we have no problem with HTTP mapping? How can we test that? Who knows? Right? Okay, so how to test that? Okay, yes, so there is a special tool in Spring, basically, that allows you to test that. And the thing is that, because otherwise it's very hard, so you set up some test context. In this test context with a special annotations, you create mocked services. This is all like more and more annotations, and finally you test something which works more or less as the real application. It is, however, a little bit complicated. It's nothing like this easy test, simple test we had before, just a new and something. It's not as easy as on a TDD school. You have to learn a lot of stuff, and mostly I see people doing projects, they don't even know something like this exists. So point for you, you knew that. So, and the problem is, if we have this controller, the Spring has to set up everything. It has to read your class, has to start it, and has to then find out what mappings you have, what dependencies, and everything is depends on the Spring. If you have a constructor, if you create it simply with new, it just will be not working. It's just wrong. So people even that spend a lot of time in Spring environment or Java E, whatever, they learn that new is kind of forbidden word in Java. We don't do that. Of course, because in object-oriented languages, you never create objects with new. That's, of course, stupid idea. That's what people learn, because new is dangerous. And then another problem. So let's forget about this controller. There is a way to test it. But now let's test this pairing socks. Can you test that the transaction really works? That, for instance, how to test that the transaction really, that the transactional method is really a transactional? Who has idea? It's very hard. And is it stupid question? Is it stupid idea to test the transactional annotation? So you might think so, but this year, at the beginning of this year, I had an application. I took part in the development, and that was an application that was 18 months on production in some bigger company, and appeared that this annotation wasn't working anywhere in the code. It's just, so imagine you have like banking system, whatever, it's a system in bank, let's say, and it has absolutely no transactions because this annotation is not working. On the other hand, which is cool, it worked on tests. There were tests, and it worked on tests. So the thing is, why? What could happen that the transactional annotation is not working? So give me ideas. Who had this problem that one day you have annotation like security annotation, or transactional or something, and it stops working? What could happen? So, yeah, you have a private method. So the thing is, who would be that stupid to have a private method that's annotated? Most of people, does anybody know why transactional method cannot be private? Because of proxy. Someone knows this. I'll say, everybody knows this, like raise your hands. Because of proxy, annotated method cannot be private. Okay. Try to explain it to juniors, okay? The thing is, that's reason number one, and if someone says it's stupid to have a private methods that are annotated, it happens after refactoring quite often. If you don't spot it, then you have a problem. Then other thing, who knew about this? This is like really funny story. You call the method is public, everything works fine. You just move it to the same bin. Maybe you had two classes, and now you have one because you simplified something, and transactional stops working. Why it stops working? Who knows? Because of proxy. Can you explain that to junior? What's the proxy? Why this problem is? So it will work if you call it to another bin, but if you call yourself with this, it won't. Cool. Or someone by mistake. It happens. There was a constructor, so I created the class by constructor, and I just forgotten this is something that Spring is about to inject. It happens after refactoring. So, oh, this is cool. We have now parallel streams. We have a lot of threads. And what will happen with transactional if it just goes between different threads? It's on a different thread than your request is starting. Sorry? Yeah. This just doesn't work. But we have parallel streams. We have a lot of possibilities, like executors, to call something in a different thread. And you know, there is a solution in Spring for that. Yet another set of annotations, and you can do that. So, and that's the thing that actually happened. You know that transactional annotation as a class wasn't deployed. Everything was deployed because this one wasn't. It is more complicated. I don't want to waste time to explain what exactly has happened. But the thing is that during the test, one additional jar was there. But on the production, it wasn't. And everything was working fine. Just JVM wasn't finding one of the classes. And JVM has a very funny logic. If it can't load annotation, it just doesn't say to you, class not def found. It just ignores it. This is really cool, because then Spring had no chances even to find out we had something like transactional. Or even something like someone puts an aspect, because you can create own aspects, intercepts or whatever, and you deploy it, and this aspect messes something with transaction. It can happen, so you just have another jar from another team, you don't even know what they do, and it magically starts, because Spring is analyzing all your classes, and it's magically there, and it destroys your transaction. It can happen. This one last is really artificial, but it might happen. I've never really seen that. Well, so this is like code that looks very simple, if you write like that, but the minefield. It's like every line, after every refactoring, something wrong might happen. I don't like to code like that. I love when I compile something, that it works, when I test it, that I can trust the test. So what I think we've achieved with a, let's say, mainstream, we have a clean code. I still remember 20 years ago, while I was doing my first Java systems, clean code for me was writing a lot of comments. And I remember those comments, like here ends if statement from line 2040. Who has seen such comments? Yeah, that was really cool. But it is way, way better now. We know how to write shorter methods. The code that really tells what it does. It's readable. That's really great thing Uncle Bob has changed. I think we can name him responsible for that. And the problem is that this readable code, even if you know what it's intended to do, it can be still complex behind because of proxy and thread local and reflection. You have something very simple, but I have it quite often. Each month, discussion with architects, we see something and we, in Spring, a construct, and we have no idea if it's correct or not because of proxy, of course. You need to know how this thing internally works in order to use that. And you will have tests, and tests are always green. That's so cool. It just doesn't work on production. Can we do better? So, can we do a simpler code that has no proxy behind? And can we work like that? So, let's talk about something that I would call pure code. By the way, I have never really seen this term, like pure code. Who knows what's a pure function? Pure function. Okay, so some people, pure function is a term, something you know from functional programming. It simply means that the function doesn't do any side effects. It's like if you put something as input, it will have one exact output, and you can test that. That's easy, and this output will never change. So this is like core concept of functional programming. But let's say about having functional, Java isn't functional programming language, but we can have more or less pure functions in Java. And but pure means, for instance, it cannot really start some proxies behind, because then you can't really reason about it. Nobody knows what's happening. So let's think about code. Let's talk about code without magic behind. The code that when you compile it, it will probably work. Of course, the word probably is very important. But if you test it, then it means it must work, because the same code with the same internals will be working on production. So that's the idea. And the problem is, like a few years ago, I thought, with Spring it's just impossible. And that's our mainstream. It's just impossible because we have those strange constructs behind. How can I create pure function if I have unknown number of aspects, interceptors that deal with my code? So the thing is Spring, like the source of the problem, is Spring bad thing? Should we blame? Who is blaming Spring? All those bad people from Pivotal, they created this ugly thing. No. Those are very smart people. The thing is that they had to adapt themselves. They did something that was really a good thing for its time, because they had to fit to Java EE, to be fitting into Java EE world. And basically, Spring inherits the problems. The core concept of doing web in Java EE is servlet. And servlet exactly is a class that's magically started by your application server. You can't really, for instance, put some dependencies to the servlet. It must be starting. So Spring was like really good idea to create something that at least way better testable than servlets. And they did it. It was working. It was really okay. But the thing is that we've changed. The mainstream has changed. We now have lambdas in Java, and lambdas, that's only a small thing. But we slowly, in the last years, learned how to do functional programming. It's not only about lambdas. We've learned a lot about monads. I will show you later a little bit about it and all that stuff. And now we have better possibilities. And the thing is that those smart guys, they created in Spring 5 something that goes beyond those limitations that we have. That is way more fitting to this functional non-magic word, and it's called Spring Web Flux. Who has tried so far Spring Web Flux? Who has tried it in a functional way? Oh, okay. So you are a good audience. I'm about to explain you how to do that very quickly. I'm not going to repeat documentation of Spring because it's quite good. They are really good at documenting stuff. So this is only a couple of things that you have to look at. Okay, so let's go to the code. Okay, so first I will start with Java. This is like Java. Oh, I will make it bigger. This is like a Java, and you see there is a main method. That's very important. Every good story always starts with a main method. Don't do these other ways like application servers. Forget about them. Those are really crazy things. So what we do, we can define our routing, this time without magic. Like I create router function. So what's the router function? Function that takes some path from HTTP on a server and creates answers. So something like a top-level container for request to response mapping. And then I say that if there is a get with this path, and by the way, I will be doing very, very stupid Fibonacci implementation. This you should really remember, because this Fibonacci, if you are on any job interview and you write this Fibonacci implementation, you definitely gonna have work. So be careful. So I say that n is I parsed from request, this n. This is easy. Like I defined mapping in my routing. If someone is doing get on Fibonacci with n, I just parse this n. And if n is smaller than 2, I will just do it like that. Oh, it looks like a lot of work, a lot of effort in Java to write this answer. But basically, that's it. You can compose it to one function and save yourself a lot of work in a normal project. I'm just showing you everything, the full syntax. So if it's less than 2, we just do it this way. But what if it's bigger? Then we will create something crazy. We'll recursively call ourselves. That's really a stupid idea. recursive Fibonacci is a stupid thing, but recursive Fibonacci on HTTP level, oh, that must be awesome. So, okay. I won't explain all the lines that we have here. Who knows? Okay, but a couple of concepts. What's mono? What is mono? Okay, who knows, who has heard about promise? Promise in JavaScript. So mono is a promise. It promises me that there will be some integer later. And how I do that, basically it's like composing of promises. This is really, when you work with Spring 5 and with this mono, you really learn politics. Because politics is all about promises. And how you deal with that. You get a promise that there will be a result from this web client. And if you get a promise of result, you can create another promise that from this result you compose that there is another promise that I can take as a string. That's a second promise, and then you compose them. And finally, if you have a promise of string, you can map the promise from promise of string to promise of int. That's this map. Okay, so we will have one promise. So let's create another promise. And what's really important, this code doesn't stop here. It goes farther because you only take a promise and you go farther. It doesn't block, doesn't delay on anything. It just goes farther. So this is really cool for if you want to utilize your CPU, really. Okay, I will explain it later. So we have the same, more or less the same copy. That's copy-paste. But you see, I'm not doing copy-paste. I'm writing again the same. So I'm so much better. Okay, we have two promises. How to make a final answer. And our final answer will be a promise too. Promise that there will be answer as a string. How do I do that? I take n1 and I flat map it with this other n2. Why it's flat map there? Who knows? It's very easy. Mapping, you know. You can map from string to integer using parseInt. Flat map is more or less the same, but the thing is that if you map from something to mono of something, you will get at the end mono of string. So I don't want to give someone promise of promise, because that's stupid. So you have to flatten that, because this n2 is a promise. So if I map it, I'll have a promise of something. So I'm mapping with integer to promise of integer. Let's flat it, make it flatten. So we have one level of insanity of promises, and that's how now what is really important in this Spring Web Flux, I don't wait for the result. I just return from my method, from this mapping, I just return the promise. Just say that it's a promise of this. Okay. And more or less, I would be almost done, but the thing is, that's not all. So I have to also start the server with something called netty. So I do it like this. First, I will even create a test for that, like map localhost, blah, 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 Fibonacci of 6. I will just test if it works, because I want to. You see, I'm using the same client. This time, I will block. I will block maximum 1 minute, and then, okay, this. And this is like, well, my mouse is not really working correctly. One thing too far. I'm missing here a server part. Okay, just a moment. I will finish it to the final. It's like, finally, I have to write something like that. Sorry, to make it shorten, because I see I don't have much time. This is how I start the server. Basically, you see, this is very easy code. There is no magic inside. I just do one by line, the Fibonacci, then I start the server. It's just absolute nothing like reflection or something like that happens here. And then we can test it. It might work. I don't know. It's a demo effect, you know, of course. Sometimes it works, sometimes not. We can have a Fibonacci. By the way, on the server there is Maven. That's why it's so slow. But you see, finally it was 8. So like 6th sequence number of Fibonacci is 8. You can check it later on, you know. But this presentation is not about Fibonacci. But remember this. This was really the coolest implementation, almost the best one you can ever see. So the thing is, if you try it with a classical architecture, with servlet or Spring Classical, it wouldn't even work. And I had this, okay, I didn't have a Fibonacci on production, but I had the problem, exactly. If you do a Fibonacci like with 12 on a Tomcat with Spring, it wouldn't work. Who knows why? Sorry? Blocking and basically deadlocking on a thread pool. Because each Fibonacci call makes two another calls. These another calls makes two other. And if you have a Tomcat, typical architecture is we have one request and it involves one thread. And in Tomcat, so we can even count how many threads will be involved if you have a Fibonacci of 12 or of 20. That's a lot of them. And that's not even the biggest problem, because it will deadlock because there is something like the thread pool limit, and after this is exhausted, then we have a queue. And I will leave you as a homework to test it, that it really, you can't calculate Fibonacci classically with a Spring or whatever, with one request, one thread, because you will always basically deadlock on this queue. However, with this approach, with promises, it will basically work. Of course, it will be very unperformant, like calculating Fibonacci of 20. It's really takes almost as much time as this presentation, but it works. It finishes. So what's non-blocking architecture? Because the thing here important is not to block. This is what Spring Flux does. We don't block, we only give promises. So what does it mean from a perspective? Normally you have one request, one thread. The thread is involved totally with processing of one request. This is like you are working in an office and someone asks you for, I need this report. And you know, oh, you can't create this report, you need some Joe who has access to database. So you call Joe and you are asking him, can you please do me this SQL query? And you can do it in two ways. In one way, that it's very natural for us, we'll just call Joe, we'll ask him, and we'll wait till he answers. It will take a lot of time, and we'll be busy waiting. What else can we do? We can simply call Joe, send him instant message that please do this query, and when you are finished, just give me the results. And then I can do something else. This is how non-blocking architecture works. You basically call some asynchronous I/O, asynchronous sources, you tell what you expect, and they're like asynchronous file system network. When they have answer, they put it basically again to you as another task. So again, when Joe answers, you get something in instant message, and it's new piece of job for you to be done. And then you know who asked this, and you send him. So basically, non-blocking architecture is working in some kind of a thread loop, event loop, that you take some piece of a job from top, work on that, and put it further. Okay, why it's so cool? Because this way, you save yourself a lot of time on thread switching. And that's very important. Who has seen this picture before? Not many people. Basically, our servers, when we look at our computers, the CPU is very fast, but the RAM and disk are very slow. And the real bottleneck today that you see in most of systems is in fact the RAM. Memory is slow. If you ask from something from memory, it's slow. And the thing is that processor is only having this 4 gigahertz if it's working on things in cache. And it can only have things in cache if it loaded it before from memory. And then it can work on that, and it's cool. But if you have to switch to the different sets of data, because you have something spread in memory, you are very inefficient. You are mostly waiting for things to be loaded in cache. And this is horrible because you have 4 gigahertz processor, but it is 100 times slower. In reality, it means that you are working on Pentium 1, 40 megahertz. That's not cool. And the thing is that if you have something like a request, let's imagine this is you are doing this job. One request, one thread. You are working on something. You have data in cache because you've gathered from Joe one set of data, from another guy another, and you have this all in cache. And then you do it. You've all calculated everything. You know, almost to send the response to other guy, the one to ask. But then, because you are one of the 1,000 threads, comes the thread scheduler and says, oh, no, your time is gone. I'm switching to another thread. And now everything you have in cache is just wasted. Another thread comes on the same core in CPU, has to load everything from cache. And by the time it loaded comes a thread scheduler because we have 1,000 threads and and switches to another. So if we do the jobs that we do job from A to Z, like from the beginning to an end, and only switch in a moment that we anyhow have to wait because we have to do some I/O, and then it will be way more efficient than just random switching. This is like the picture. If you do like multitasking, in reality you have this black pauses. It means the time when caches are loading your data. So it would way better to just not have random switches, to have switches on a course in a moment you anyhow wanted to do something else because, for instance, you just called someone, asked the database, and now you can do anything, let's do another job. Okay, this is why this architecture is incredibly performant. This is like the reason number one people use non-blocking architecture, Node.js and stuff like that, because it's really sympathetic to your core, to CPU caches. But I think, for me, that's not that important. For me, more important is that this is very simple code to reason. Okay, it works. I did systems like that. It's way easier to test because you've seen, I could start the server in the main method. I can start the server in a test method. I can check the results. That's a meaningful because the same code would be working on production. It's way safer then. And it's my boilerplate. You've seen this code. It wasn't looking nicely, yes? It was functional Java. It's like writing a lot of boilerplate, especially because Java is not friendly toward immutable structures. And in functional programming, you would rather use a lot of immutable objects. So this is the problem that I had. And then there was a solution for that problem. If there's a problem, there must be a solution. Solution is Kotlin. So let's talk about Kotlin for a moment. This is like class in Java, a person that has three fields, then getters, setters, then constructor, then equals, hash code. And that's not even all, because if we want it to be immutable, then we create, for instance, let's create person that is older when we internally construct. And then we would have like more other methods like that. That's a lot of code to write. It's really not nice. Of course, you can generate it with IntelliJ, but it's still not nice, a lot of code. Do you know how this code looks in Kotlin? Yes? One line. This is one line. Like this. Data class person, and it's done. And the thing is, I always was thinking, oh, this is just the same with case classes in Scala. This is just syntax sugar. But this is the syntax sugar that completely changed the way your program. Because if doing immutable objects, immutable classes is so easy, then you really do that. You don't save your times and do mutability again because it's just easier. You don't have to write that much code. Okay, so the thing is, by the way, Kotlin is not only that. There are a lot of cool things in Kotlin, like, just a moment, I just see it. Immutability with sin. We have, you know that Java 10 has vars. Who has heard about it? Yeah, we will have vars. And the thing is that the vars in Java, the new version, will be very limited. You can only use them as a field, as a local variable. In Kotlin, we only have vals and vars, and they are everywhere. Like for declaring a field of the class, in constructor, arguments of method, it's very consistent syntax. Actually, it's easier than Java. It's just easier. It's less to learn. Or if expression. This is something really cool. So if it's no, you can, for instance, write code like that. Assign if expression value to some variable. That's so cool. Or smart casting. This is really funny thing, but also works like that. You don't have to cast everything. If something is a class of something, then you know it in the code before. Or null safety. This is really cool, but I won't spend much time explaining that. And or named params. So if you call a function that has 3 ints, you can finally name them. Of course, IntelliJ in Java solves this problem for you, but it's only like IDE solved problem. This is on the language level solved. So there are a lot of cool things in Kotlin, and Kotlin is still a very easy language to learn. I call it Scala minus minus, simply. Because it's Scala without all these things that cause headaches for Java developers. You can learn in 50 minutes Kotlin, really. I promise you. You won't learn everything in Kotlin that will be good enough to write code on your own and understand what your colleagues are doing. Really, 15 minutes. It's just so easy. If you know Java, of course. This is very important assumption. So how would the code with WebFlux look in Kotlin at the beginning? It's not really way better this time. We can make it smarter, but it's like in Kotlin, this WebFlux we can call like that. But on this level, nothing really changed. What's changed is inside, what you do behind all this mapping from request to response. And this is how it looks in more or less something productive. So we have more get methods, and it looks like that. So this is from some other sample code. But let's talk about this transaction at the beginning. You remember this transactional annotation. What would happen if instead of having some magic, we would write it on hand? And it doesn't mean that for every method that you have, you write begin transaction, blah. That would be a very stupid idea. You have only one function in your system that is called doing transaction. And its function takes lambdas argument. By the way, that's how you can easily write lambdas in Kotlin. You could have function in Java, use a type from Java, but this is like just fancy syntax, yeah? So DB operation is something that takes database session and returns you some result. This is in fact generic. And then inside this method, you open the session, begin, and that's very important. And you call this operation, and it's, by the way, it's still doable in Java. Then you commit transaction or rollback if something wrong happened. And this is something you have one time in your system. And by the way, there is, for instance, library JOQ, Juke, and it has this operation. So you don't even have to write it. And then, for instance, if I am writing transactional method that is duplicating sucks, I can do it like that. Takes, doing transaction, session, and then I write my code. It's exactly the same number of lines added as adding this as annotation. It's not really more code to be, and this code always works without any magic. That's so cool. So what about monads? You've heard, of course, there are monads. Monads are easy. Who knows monads? Okay. So this is the Kotlin code that demonstrates null safety. We have 3 interfaces, like user repository, user n. N is from using null, or group n. And let's think about something. We want to find the user, and if the user exists, we want to check the group that the user belongs. If a group exists, we look for the group owner. Finally, if there is a group owner, we email him, if he has email. A lot of null checks. This looks really bad, but you can in fact encode null checking in something called monad. And who knows how this monad is called? Sorry? No, monad. I'm talking about monad, not about the syntax. So monad is really easy. It's option. By the way, in Java you have optional, but I'm using option from package called Vavr. I will tell later why. You could have it here optional. And what optional has, or option, is all this if checking stupid logic is written here inside below this flat map. And again, it's no magic. It's just the code. You can look at the flat map implementation. It's very easy code. You can test it. This is how you deal with option or optional. However, there is a construct in exactly Elvis operator. That's not Elvis, sorry. That's other operator in Kotlin that you can do the same on a language level. By the way, I don't use it because I find monad are more interesting. Why? So this is a Kotlin native solution. Because one day you may think, oh, I don't only need to know that something didn't exist. I want to know why it didn't exist. So instead of option, I write try. Try is basically you have object or you have exception. And then you don't even change the code. So it's like you change array list to linked list because of something, and because you used only interface, you don't have to adapt all your code, and it would work. That's so awesome. So basically, if you write something with map and flap map, you are using monads. And this is for basically this is always, monads are things like construct containers for side effects, for non-existence, like optional, for exceptions, like try or either, or for even list is a monad, or future is a monad. And those monads are greatly implemented in a package called Vavr. This is how this is written. I do recommend this package for you. If you work functional, pure programming, then Vavr fits perfectly. It's way better than Java util. It has immutable lists and immutable hash maps. It's kind of a new Guava, if you know Guava. So I say, if you do business programming, you are not counting like millions of objects in a vector or in an array, then use Vavr instead of Java util collections. You know why? Because it's even faster. Because most of the collections we have if you do some business software are like empty, 1 element long or even 10. On such code, I don't have time to show you that. This is even way faster. If you have collection of million elements, you might consider Java util for that. It's faster. Of course, it's faster for such huge list, but this is way safer. And we rather look for safety mostly than for performance at first. And all of that composes to the nice thing that I am right now using in my new systems. Like, I have Spring 5 Web Flux, so this is the really answer how to write servers non-magically. This is just this DSL, domain-specific language, for writing my routing, and so that I start with main. There is no class path scanning. This server starts in seconds, because it's just everything in a right method. So I can even start it in test method, because it doesn't cost anything. They even have something special for testing it even faster. So this is really well done work. Then I have Vavr IO with immutable structures. So basically I was in the past using Spring 5, last year I started with Java and Vavr IO. It was already great. I already could write a program that I was sure they were exactly on test as on production, without magic. And then I realized that Kotlin is the language that makes it even better for me. It's really, this switch, I made it one day. And I have codes when I mix Java and Kotlin. It's not a problem. That's also the cool thing about Kotlin. You can mix it with a Java code without any problems. So then I was even more encouraged to write immutable code, pure functions, because it's so easy without boilerplate in Kotlin. And then finally, I didn't have much time, this mono and flux that with mono. This is something that comes from Project Reactor. And what is Project Reactor? Let's say this is reactive stream implementation. It's exactly those mono that you've seen. This is something like Iber monad. So some monad that has also operations like checking for exceptions, retrying operations, etc. So, by the way, you can't even avoid that because Spring 5 uses that. So this all naturally fits together like puzzles. And if you do systems like that, they are just working without any, let's say, magic. Exactly, they compile, then they probably work. If the test passes, you are basically sure, because no matter what evil jars are injected in your code, you are just starting with main, and you can exactly debug line by line what's happening. If a transaction doesn't work, you can write test for that, or you can even debug it. Yeah, compare it to where would you put debug line if, for instance, security check doesn't work in Spring. So there's security the same. So to more or less conclude this talk, I encourage you to check the Spring Web Flux. It has a great documentation. There is something else I didn't have time to mention. For years, I was using something called Ratpack. So the Spring Web Flux is, I would say, yet another implementation of functional servers in Java, non-blocking server. Ratpack is one that is very, very mature. Spring Web Flux you can still consider something new. Ratpack is something that was there for ages, let's say, and is really productive, proven. Spring Boot plus Kotlin, very simple example. There are examples on the net. I put one another. This is very simple. I'm building right now something more meaningful, more full. I have a full example of really pure functional coding with exactly Ratpack, so let's say old Spring like WebFlux, you might look at this, and with Java. So if you are more Java developer and don't want to switch to Kotlin, you can use it. Basically, it's even something I do recommend. Do small steps. Think, if you don't learn all the stuff at once, learn maybe reactive stream like project reactor or RX Java, learn then, or maybe before, you choose what you need. On Spring Web Flux for functional routing, and one day you will see that now it's time to learn Kotlin because it makes all fitting together. The cool thing is that I've shown you the puzzles, they perfectly fit, but the cool stuff, you don't have to choose all of them. Any single of them is making your code better, more safer. And that's all. If you have questions, you can message me, of course, on the Twitter. You see my Twitter account. Are there questions now? Because I'm about to finish. Oh, no questions? Then I think you're going for lunch right now, or?
Yeah.
Yeah, so. Thank you.